Hello, my name is Wayne Godsoe from the Avaya Serviceability Engineering team. This tech tip will cover the steps to configure the trace utility when troubleshooting the Avaya ERS8800. The ERS8800 trace utility is used to observe the detailed status of a software module at any given time. The results of the trace can be analyzed when troubleshooting the system. Using the trace tool inappropriately can cause primary CPU lockup conditions, system degradation, and loss of access to the switch. You should use the trace utility with caution. The trace toolset can be used to trace multiple modules simultaneously and provides options to specify the verbosity level of the output. You should avoid leaving traces active for extended periods of time. For high CPU utilization situations, less than 5 seconds is usually sufficient to identify the cause. The trace utility configurable verbosity levels are as follows. 0 is disabled, 1 is very terse, 2 is terse, 3 the trace data will be very verbose, and finally 4 is full verbosity mode. It's good practice to start with level 1 or 2 and work your way up in the verbosity level when isolating a problem. A specific module ID is defined when configuring the trace utility. There are over 100 separate modules supported by the trace utility. A full list of module IDs supported by the trace utility can be viewed on the system using the trace mod ID list command. Common modules include 7 being the hardware interface, 9 identifies the CP port, 13 is the main process, 23 will be the IGMP process, and 25 identifies the MLT service. In our tech tip example, we'll log into the system with read-write-all privileges using the RWA user account and RWA password. We'll view the current module IDs supported by the trace utility using the trace mod ID list command. We'll clear all previous trace data present on the system using the trace clear command. We'll start a trace for module ID 9 with the verbosity level of 3. We'll stop the current trace running on module ID 9 after a few seconds with the trace off command. We'll view the captured trace data using the show trace file command. Next, we'll clear the trace data to clean up using the trace clear command. And finally, we'll verify the trace file cleanup was successful using the show trace file command. In our example, we'll log into the console with read-write-all user account and read-write-all password. Now let's view the current module IDs supported by the trace utility using the trace mod ID list command. The output will give us the numerical identifier for each module. Now we'll clear any previous trace data present on the system using the trace clear command. Now we'll start a trace for the module ID number 9 using the trace verbosity level of 3 with the following command. Now that we've let the trace run for a few seconds on module ID number 9, we'll turn it off with the trace off command. Now we'll view the captured trace data using the show trace file command. From the output, we can see all trace data associated with module ID number 9, which we know from our module ID list was the CP port. The captured data will be used for fault isolation at this point. Next, we'll clear all trace data to clean up the system using the trace clear command once again. Finally, we'll verify the trace file cleanup was successful using the show trace file. As you can see, configuring the trace utility on the Avaya ERS8800 is a quick and easy process. The trace utility is an extremely useful tool for fault isolation when troubleshooting the Avaya ERS8800 system. Thank you for your time today. We welcome comments, questions, and feedback at mentor@avaya.com or on Twitter @Avaya Mentor. For more details or related information, please visit support.avaya.com. Thank you for choosing Avaya.